Hello class. So today we're going to go ahead and learn about how to graph sine and cosine. So the first thing that we need to go ahead and do is work with this right here, just referring back to the unit circle. So in the unit circle, I want you to know that this point right here is 0 degrees. Then we're also known as 0 radians. This point right here is 90 degrees, and we also know that is pi over 2. This point right here is pi, and this point right here is another 90, so it's 270, or also known as 3 pi over 2. And a whole rotation will give me 2 pi. Awesome. Now, from here, we can also know that there's coordinates associated with these points. So this point right here, from the origin, I'm going to go ahead and go right one, so this coordinate would be 1 and 0. From the origin up, this coordinate would be 0 movement on the horizontal, so it's going to be 0, 1, because my height right here is 1. Remember, the radius of this unit circle is 1. So from the origin all the way to the to the left is this point right here. So I moved 1 to the left, so -1 is a position and the height is 0. And we go ahead and see that down here, I go 0 movement on the horizontal, and then 1 down, so it's -1. And back to 2 pi, I give the same coordinate, 1 and 0 here. Awesome. So the next thing that I need you to know that we just found these x, y coordinates. The x's are associated with cosine thetas, and the y's are associated with sine thetas. Okay, so the rest is pretty self-explanatory. All you're finding here is pretty much a function. So we need to find out sine is associated with my y's. Technical difficulties. Okay, and my x's is the angle. So 0 degrees. 0 degrees right here. 0 degrees, I have that it's this coordinate, and my y is 0. At pi over 2, I have that I'm going to go ahead and use the y coordinate. The y is 1. And at pi, my y coordinate is 0. At pi over 2, at 3 pi over 2, it's right here. And it shows me that my y coordinate is this -1. And at 2 pi, my y coordinate is 0. This is the pattern that it will go ahead and follow. If we go ahead and look at -pi over 2, that is right here on my -90, and my coordinate is associated with 0 horizontal movement and -1. So this will be -1, and -pi will be another 90, and this coordinate will be 1 left, -1, and 0. So that y coordinate is 0. So now you might be wondering, what exactly does this help me do? So this right here is actually going to go ahead and help me graph my function. So all you need is an x point and a y point to create a graph. So when x is 0 and y is 0, I have a point right here. When pi over 2 right here, y is 1. Then I have, what is that? Then at pi I have 0. At -pi over 2, my height is -1. Then at 2 pi I got 0. Now you're probably wondering what has this -pi over 2? Well, -pi over 2 is actually on the left side, -pi over 2, and that would be -1. And there's not enough space, but -pi would be at 0, so a little bit more left. That way would be my -pi. So our graph for sine looks like this. Little curved. And what I want you to know that this was one revolution around the unit circle. So therefore, if we do more revolutions, you're going to obviously continue this graph infinity to the right and infinity to the left. So our domain for sine is -infinity to positive infinity, and our range is the height that the lowest it can go, we can see is -1, and the highest it can go is +1. Awesome. That is sine. Cosine would be the same exact procedure, but instead of using y's, cosine is associated with x's, so you're going to go ahead and use the x values for this same exact graph. And you're going to notice that all that happens for cosine is that it starts at the max, then it goes to the middle, the midline, the minimum, and does the same procedure. As you can see, it just continues to infinities on both sides. That is the graph, the parent functions of sines and cosines.